Hello everyone and welcome back to the channel. Today we're taking a look at this. It's way too big to fit on the desk. Still, I really didn't think this through when I designed such a monstrous printer. Anyway, today we're going to be finally deciding on a name, and also we're going to be taking a look at some of the details of the y-axis. But before we get onto that, a quick message from today's sponsor, NordVPN. When I travelled to Prague recently for the Prague Maker Faire, the hotel had no security on the Wi-Fi at all. So I wanted to make sure that I had a VPN to get me connected to the internet securely and while retaining my privacy. I wanted to be able to manage my YouTube channel and other important things while I was away, and with NordVPN I was able to do that knowing full well that my information was not being stored and what I was doing couldn't be tracked. NordVPN has over 5,200 super fast servers across 62 countries, so wherever you want to connect to, you probably can. It even works from China and the Middle East. And there's no data logging, so you can be pretty sure that nobody knows what you're doing. Customer support is available 24/7 and you can have up to 6 simultaneous connections. With P2P sharing allowed and double data encryption for increased anonymity, you can be sure that your data is secure online. If you want to try it now, there's a link in the video description. It's risk-free with a 30-day money-back guarantee. Thank you for listening. Now let's get on with the main video. So of the 5 or 6 names, whatever it was, that we looked at in the last video, quite a little while ago now, one of them seemed to stand out to everyone more than all the others, which I suppose was good. It was a fairly, is unanimous the right word? Everyone pretty much, well, nearly half the people, 46%, agreed on one name, and I also quite like the name, so that's the one we're going with, and that is the Extrudinator. Yeah, so that's the name. Congratulations. Cool. Now we've got a name, now let's look at some details of the design. So I made a list off the top of my head of things that I want to mention. So the first thing is the weight of the y-axis. It is really quite heavy. So you've got this huge construction here, which is 6mm aluminium for the kind of base, which holds the wheels to the rail. And then you've got another piece of 6mm aluminium for the bed at the top. The problem with weight is it's the kind of precursor to ghosting, if you like. So having a lot of weight means that you're going to stretch your belts more, means you need more torque from your motor and all this kind of stuff. So there's a whole load of things that are impacted by having a very large weight on your bed. Because it's very heavy and because my components at the moment are fairly standard, kind of normal, and therefore weak compared to the weight of the bed, you have to have very low acceleration in order to prevent the high forces, which is what stretches the belt and results in the ghosting. So the print speed of this, speed can go quite high. Acceleration has to stay fairly low. But I mean, it still prints at a reasonable pace, so it's not too much of a concern at the moment, but weight is one of the things I'm going to be looking at and does drive a lot of the other factors that we're going to talk about when it comes to design of the y-axis. One of the things I'm looking at as part of this is this material. It's called FR4. I can't remember. It's like a PCB kind of woven plastic material. It's really rigid, so it's difficult to flex, which is ideal. It's, as far as I can tell, I think it's lighter than aluminium. I've not actually checked the density, but this is a fairly thick plate and it's fairly small. This is going to be maybe go on a printer like this. It's actually quite heavy. It's heavier than I thought it was. 6mm though, it's pretty thick. This one here is the size suitable for this, and this is only 3mm thick, and again, still really, really rigid. Don't know how easy it is to machine, or to drill holes in, or to cut, or anything like that, but maybe a couple of sheets of this, replacing the aluminium, will bring down the weight quite a lot. So is it necessarily a problem right now? No. It does print, and it can print actually pretty good. Should I be trying to reduce the weight in order to increase the acceleration and improve the print speeds? Yes. So that's why we've covered that one. So the belt that we're using in here at the moment is a really standard 3D printer belt, which is a 6mm wide 2GT or GT2, whichever way you like to call it. I think technically it's 2GT, but all the Chinese vendors sell it as GT2. Anyway, it's a 2mm pitch belt of the standard tooth profile you'll see on pretty much every 3D printer. And The reason why this is not ideal is in a belt, what you're trying to reduce is the amount of stretching. So stretching is obviously caused by the force. It's just like a spring. As you pull it, it stretches. The belt is no different. It feels obviously very not stretchy. That's kind of the design of the belt, and why it has, I think, aramid fibers lengthways in the belt in order to prevent it from stretching, but it still has some stretch. So the thicker and wider you get your belt, the less likely you are to have problems with stretching for any given weight. The other factor of the belt is the size of the tooth profile. Now, I'm not exactly certain why a larger tooth profile would help, but I'm fairly sure it will. So I think what it will reduce is the chance of the belt skipping over the teeth due to high acceleration. Now, I've not actually seen a problem with that, but I think what I'm likely to find is just larger, thicker belts just come with larger teeth anyway, because a larger, thicker belt will not bend as much, so you have to have larger teeth. I think that's probably what this is going to all come round to. Now, the next part of that is having a larger belt will probably also mean I have to have a larger pulley. So at the moment, the pulley is 16 teeth, I believe, or 20 teeth. And that is kind of a gearing ratio between the stepper motor and the belt movement. Well, basically the movement of the the Y carriage. So the larger that wheel is, the less torque you get from your motor, but the more speed you get. Now, if we go larger belt and we have to go larger pulley, we're going to get less torque, less effective torque, if you like, out of the motor. So the next upgrade that would come with that, well, all at the same time, would be to increase the size of the stepper motor. So potentially we can just increase the body length of the NEMA 17, as body length typically translates to maximum peak torque or holding torque. But I think the more likely scenario is that it would be wise to move to a NEMA 23. So a much larger body, and therefore used to having much higher torque. I mean, much higher torques. So that will be then really capable of flinging that massive bed around. So I wouldn't have to consider changing the materials or thicknesses of that bed, and it could stay as it is. So yeah, at the moment, the two options are reduce the mass of the bed, keep the kinematic system, change the kinematic system, and keep the mass of the bed. The next thing I want to talk about is the wheels. So under the bed carriage, it's all held up by a few wheels. You can see the wheels. So at the moment, there's a total of 4 wheels. There's 2 each side of the carriage. So because the bed carriage is quite heavy, the wheels take quite a lot of load, and they're taking that load in a fairly unusual direction, I think. I don't think the wheels are designed to be loaded kind of axially, so that's kind of sideways onto the wheel, which is what they are here. So the bed is obviously pushing down in that direction, and that's not ideal for the loading on the wheels. Now, it would be wise probably to have maybe a total of 6 wheels, which would be 3 on each side, and that would spread the load evenly between more wheels and therefore reduce the problem. The downside of having more wheels is that it becomes much harder to set them just right. So you may be aware of maybe the Ender 3 style printers, which you can't see. So the Ender 3 has this kind of arrangement. It has 1 wheel here, and then 1 here, and 1 here. So a total of 3 wheels, and that makes it really easy to set. These 2 are fixed, and you just change the distance between, well, basically you're setting the width that wants to grip by just changing the concentric, well, the non-concentric, if you like, nut on here. I can't remember. Eccentric, that's the word. That's how the Ender 3 does it, just a 3-wheel system. And it uses the same on the carriage and everything, and that does make it really easy to set. But obviously, with only 3 wheels, you're limited to the amount of load you can carry. With the Ender 3, it's fine, it's just a small printer. But this is quite a lot larger. So I do need to find out a sensible way of setting those 4 wheels, or maybe the 6. I'm not sure at the moment, even with 4, because you've got 2 pairs clamping separately. You can have 1 clamp and then the other still move a little bit. It is quite difficult to set even 4 wheels. Setting 6 is going to be, yeah, I mean, you're only setting 2 of them on a 4 and 3 of them on a 6, but getting them all exactly the same so that they're all applying equal amounts of pressure is not very easy. So yeah, we might be moving up to 6 wheels, but that would actually mean a change of the plate. If we do move to the FR4, then maybe we can do that at the same time. Now that we've talked about some of the kind of negatives, if you like, I guess they're not really negatives, they're maybe potential downsides. Anyway, some imperfections, potential imperfections. Let's talk about some of the good things, some of the reasons why it is what it is, and why I still think that's a fairly good decision. So, 2 aluminium 6mm plates. The top one is probably the most important of the 2 in terms of specifying the correct materials and things like that. This 6mm aluminium is a milled plate, so it's cast and milled rather than being rolled, which means over time, as you thermal cycle, which means heat it up, cool it down, heat it up, cool it down, which you will have as a 3D printer with a heated bed, it doesn't warp. So it's not going to take residual stresses because of the rolling and end up kind of warped one way or t'other or just strangely. So that's a problem we've basically eliminated by having a good material selection, which is this 6mm milled plate. So the reason for the bottom plate being 6mm thick is to have high rigidity. You need the rigidity, maybe not quite this much, I didn't actually calculate it to be fair, but the reason you need high rigidity is with this large build volume, you can put a lot of material into it. And so you obviously don't want your kind of Z height to change after adding all of that material. So by having a rigid plate at the base, you can reduce the amount that it's going to bend as a result of the built material. In reality though, am I going to be filling this build volume with material? Probably not. Do I have many spools that are more than 1 kilo? Currently, okay, I have 2 now, but I mean, realistically, am I ever going to be trying to fill this build volume with like really dense, like 5 kilos of power? Probably not. So that's probably a little bit overkill in terms of the rigidity requirements, but it also just looks pretty cool. Okie dokie, let's carry on. So as I mentioned, we got a Y-axis belt holder in here, and that basically mounts the belt to the base of the Y carriage. And it's right down in the middle, so it's really difficult to see. No matter where I try and put the camera, you're just not going to be able to see that. A couple of problems with it. Actually, no, this is really one problem. It's made out of plastic. It's a 3D printed part. One of the key aims for this printer was to have no 3D printed parts that provide structural integrity. So, I mean, this is 3D printed, but you could take that 3D printed print off and it would function exactly the same. It'd just be a little bit less safe because you'd have sharp ends and your motor sticking out and things like that. Again, there's a kind of box over the power supply here. It stops you shorting your fingers on the electrical connections, but it doesn't actually add any strength or printing quality or make any improvements really to the printer. And that's it. That's kind of standard for all the printed parts you see. Actually, this one's kind of functional, I suppose. It's holding the belt carriage, as are these, but they don't affect print quality as much as they're just there to help other aspects. Whereas that one down there, that's right under the bed, holding the belt to the Y carriage, is fundamental to the motion of the Y-axis. Now, it is printed really rigid, really strong. I don't think it's going to be causing much ghosting in terms of its own flexing, but if we increase the belt torque and end up with thicker, stronger belts, the structural integrity of that mount is going to probably be a limitation. What I'd like to do is have a metallic mount that is really solidly mounted to the underside of the bed, but there just doesn't seem to be a kind of off-the-shelf standard part, which is kind of what I'm trying to use here, that mounts a belt at that angle to a plate at that angle. And that's what I've got here. I've got the belt coming in vertically like this and the bed mounted like this. I want it to kind of maybe come in and wrap round something and then maybe crimp on the other side. I need a thing that does the thing that the printed part does. Obviously the printed part is fine for doing what it's doing, but I need the same thing out of something that's metallic. That would be just great. An off-the-shelf part would be absolutely perfect. Next we got the straightness of this C beam. Now the beam itself, I'm fairly sure, is going to be pretty straight. It's and extrusion, so they're pretty much always high quality. The challenge is not in having that beam straight itself, but mounting it straight onto the printer. It's quite easy to remove the entire assembly here because it's fairly independent from the rest of the printer. So with, I think, 6 screws, the whole thing will just lift off. Might have to remove this drag chain and cables and connectors and stuff as well, but mainly it's really easy to remove. However, it's also not very its place is really easy to adjust. So if you just take off those screws, you can kind of slide it all the way along and maybe do a little rotation. So the problem with that is that I'm not absolutely sure that it's square. And I'm not sure how I'm going to ensure that it is square. I can kind of measure to the edge of the frame, but how do I know that that's perfectly square? And how am I going to get something that's going to ensure that? So while I do like the fact that it is mounted to a rail and it can come off and be changed fairly easily. I'm not going to demonstrate that now, but it can come off fairly easily. It does mean that the actual straightness is maybe questionable. And the reason that matters is it can skew the whole print. So instead of, when you're trying to print a square, printing a square, you end up kind of with a slanted, what do you call it? More like a parallelogram. So your top and bottom, where they get drawn by the x-axis, will be straight because that's straight. However, this axis could be kind of skewed. So instead of moving straight along like that, you end up moving at an angle, drawing angled lines. So your 90 degrees is not 90 degrees, it can be like 89. Another issue along those lines is the levelness of the bed. Now, at the moment, it's mounted fairly rigidly. There's no springs, so that is one very good thing. And we're using the Pinder probe, that's the Prusa term. We're using an inductive probe to measure many, many points on the bed. I think we're doing like a 10 by 10 grid or something like that, so like huge number of points, and makes a really nice mesh, and it does all the adjustment. So the first layer at the moment prints absolutely perfectly. When I took this up to 3D Meetup UK, I didn't even do any calibration once I got there. I literally had thrown it in the car this end, driven for 3.5 hours with it all rattling around in the back of the car, got it out the other end, slapped it down, print, perfect first layer. So in terms of being able to get that first layer, not a problem. It's a very rigid frame, very rigid bed, does a good job. But I think at the moment the amount of adjustment that mesh bed leveling is having to do is more than I want it to do. What I have done is I've put shims in here which come with the bed kit, and that's what's designed to get the bed level. The problem is I'm obviously leveling it to the carriage, which again, not sure how level that is. Don't really have many methods that are super reliable in order to get that perfectly parallel. Same with the frame. I haven't got like a calibrated concrete table or anything to assemble that perfectly flat. I have got this wooden table which is fairly flat, but the problem with wood is that over time it does kind of warp and change a little bit. So I just not 100% sure how square the frame is. It's pretty good. The prints come off it, they're still pretty great. Let's flip this around and have a little bit of a talk about the bed. So here we have the bed assembly. Of course it is mains powered, which I do prefer generally on printers now, maybe apart from the ones from China, just in case the quality is not so, But for me to do one myself, definitely prefer mains powered beds. The nice thing is that for that 450 watts that I've got and 240 volts, it means the current is only 2 amps. So you can use a fairly thin gauge wire. I mean, don't go too thin, you don't want to screw yourself over, but you can have a fairly thin gauge wire. This might not be true, but I feel like it would be safer because the current is lower. It's still the mains, so definitely some added danger there. But the entire frame is grounded, as is this plate here, so which of course is connected to the top plate. So pretty much anywhere on the printer metallic is connected to something else metallic, so shouldn't have any problems with that. I think it's safer, but then I'm not an electrical engineer, so I'm not 100% sure, but I feel like it's safer because the current is much lower. DC current at like 10 amps, probably fairly lethal. To be honest, 250 volts at 2 amps, probably also fairly lethal, so maybe not that much different. The only real downside I've found to this spring steel sheet is that there's no, what I'm used to on the Mark III, the Prusa Mark III, is that I've got some things at the back to align this bed. At the moment, I can literally put it on anywhere. Like, it holds it down just fine, but I'd much rather have some locating pins, something to locate the bed so I know it's kind of in the same place as it was before. Maybe I'll find a way to integrate that. I think it would need some clips to come off of this bed, just maybe up the sides to stop you pushing off the back, maybe one of those corners so you push it to one corner and then I don't know. Something like that that just helps align it would be great. So I think that's pretty much it from me today on the Extrudinator. At last we have a name. It's only taken a few months. Congratulations, of course, to whoever it was that picked that name. 10 brownie points or whatever it is to you. I mean, you don't get a prize, but I mean, I should find out who it was. That's Axel Hoffinger. I don't know how to pronounce your name. I'm so sorry. Congratulations, you picked a good name. Well, I'll put it on the screen so people know the name. That's going to be it for today. We've obviously gone over a number of aspects about the bed design, which may or may not need improvement over time. You've probably noticed that I've been kind of not that active on YouTube, so apologies for that. Had some other things going on, some of which is that I'm trying to move towards doing more YouTube, and ironically that has resulted in me doing less. So I'm trying to get some money by other 3D printing related jobs in order to have some funds for doing 3D printing and support myself. However, that's resulted in me doing less YouTube videos because I'm trying to make some money to work on YouTube. Like, it's not worked out maybe quite how I planned, but it's going really well. So I think I'm moving in the right direction. It's just taking quite a long time. Maybe by the end of the year, we'll be at a stage where we can create back to at least weekly videos and me being able to self-support myself. Self-support, that's probably not the right. Anyway, that's a thing that's happening and why I've not been able to do as many videos as I would like. Anyway, follow me on Twitter and Instagram. Twitter is now at Adam something V3D. I'll put it in the link. I can't remember what it is now. It was obviously Copper Tech, but now CRT is now Vector 3D. So all that just kind of jiggled around a bit. Instagram, I think I've still not updated, so that's probably wrong. Facebook page, can't change the name because Facebook don't like you change it, so I'll have to create a new Facebook anyway. That's not going great. You can support me on Patreon, and that is updated. So Patreon/Vector3D, or is it V3? Again, I can't remember which one it is. It'll be in the description below. But it'd be great if you could support me because I am trying to move to do more YouTube stuff, even though it probably seems like the opposite. Anyway, bye for now.